Hello guys, in this video I'm going to show how to solve root to leaf maximum path. Right, so given a binary tree, find the root to leaf path with the maximum sum. Right, so for example, we're given this binary tree. There are a total of 3 levels, 3 layers, right? And for this tree, you can see there are a total of 4 paths from root to leaf, right? So 174, 175, 192, 197, right? Our goal here is to find the path with maximum sum, right? So what would be the result here? As you can see, the first part will sum up to 12, right? Let's write down 12. The second one is 12, 13. Third one is 10, 12 again. And final is 117, right? So the maximum sum part, the maximum sum is 9197. 197, right? So for this problem, we're given a binary tree and we need to find path, right? So probably it has something to do with depth first search, right? Whenever you have to find path, then depth first search is something that you should think of, right? So okay, I'm gonna use depth first search. But how to find the maximum sums, the path to maximum sum? The idea is simple, right? Let's think of we need to find a maximum. We have a list of number, right? We need to find the maximum number, right? So probably wanna iterate to every number. We'll compare the current number with the maximum at that moment, right? If the current number is greater than the current max, then we're gonna update the current max, right? So after iterating to every number in the list, and we're gonna have the max number, right? So the idea is the same. Wanna travel through every path, right? Using depth first search, of course. Then wanna compare the sum of the current path with sum of the maximum sum with the sum of the maximum sum. Sorry, let me say it again. So in order to find the path with maximum sum, when travels through every path, right? Gonna check the current path, sum of current path with the sum of the path with the maximum sum at that moment, right? So if the current path produce better sum, wanna update, right? The path, right? the path with maximum sum. So that's the idea. For implementations, therefore search, we're gonna use recursions, right? So we're gonna model our problem into find the max sum path, right? Considering our root, right? Considering the node at root, right? Considering the current node, right? Which is the root variable is pointing to. And because gonna call this function recursively, and gonna go in depth, right? Go down the tree in depth, and at each step gonna add up, gonna accumulate, not accumulate, gonna accumulate the current path, right? Until it reaches the leaf node, right? The leaf node. When we're at leaf node, we're gonna check, right? It means we're done with one path. We're gonna check the sum of that path with the sum of the best path currently, right? So there's a couple of things we want to pass down for recursive functions, which is the current sum, right? Which is something that we're gonna accumulate. We need to pass down the current path also, and what else? The max sum, right? Max sum currently, and what else? Best path, right? So the max sum is actually the sum of all values in the best path, and the current sum is actually can be calculated from the current path, right? So maybe we can remove these two, and because we can calculate it using these variables, so let's go this way, so we don't have to pass a lot of arguments while go in depth, right? So the root, okay, initially is the root node, right? The current part, it is an array. Best part is also an array. Initially, it current part, like we at root, right? And before traversing the root, the current part is just empty array. Best part is also an empty array, right? So okay, at each function call gonna pass the current node to root, right? So for example, the first function call will pass the node 1 into root, right? And next we'll pass node 7, node 4. So if at this step we want to add the value of current node to the current path, right? Current path, I'm gonna push the root.val. Okay, add it to the current path. What else? After adding the value of current node to the current path, wanna check, right, if it is the leaf node. A node is leaf node when it has no left node, no left child and no right child. So if root, if we don't have root dot left and we don't have root dot right, it means leaf node now. So probably we want to calculate the sum of the current path. For example, we are at 4 now. We add 4 to the current path, right? So we check. Okay, we're at root because 4 don't have left and right. So we need to sum up the current path, compare with the best path now. So it will be great if we have something like sum of current path is greater than sum of the best path, right? Then we don't have sum yet, but it is something that it's just a trivial functions that we can implement later. So if sum current path is better than this one, what wanna do is wanna update the best path, right, to best path to the current path. And if we load node and we don't want to go down any further, so I just return right here, right? So otherwise, if it comes here, it means it's not a leaf node. So it either has left or child, right? So we want to go left or right or both. So for that child of root dot left and root dot right, we only want to go down if we have the child, right? If the child is not null, we want to go further. We go further by calling this function recursively. Find maxsum. What is a node root here? It is a child. The next node that we want to visit, right? The child. Current path. Gonna pass the current path, right? It is updated with the current node. Okay? So it's a reference, right? We pass the reference down, so it's the same for every functions, right? So current path, okay. What is the best path? It's just okay. Pass down the best path also. Okay. What else we need to do here? It is after visiting the one node, right? So for example, after if we're here, if we are 7, for example, we go down to 4, right? but 4 is a leaf node, right? So we come here, then we return. It means we come back to 7. So it means, so for example, we are at 4, then our current path is 1, 7, 4. But when we come back to 7, we want to pop. We want to remove 4 out of the current path, right? So we come back 7, we want the current path should be 1, 7, right? So after visiting the child, I want to pop the value of child out of the current path, right? So that come back to 7, the current path is 1, 7, and we can go to the right, which is 5, and add 5 to the current path. So we have 1, 5, 1, 7, 5. Okay, that's it, I think. We can do a little bit of check here, because here we are accessing root.val. What if root is no initially? It will cause an error. So if we don't have root, we should return. Right. So what's left here is some functions. I want to implement it. Some. This will take in an array, and yeah, if we don't have an array, then it is default to empty array. Okay. To add up all number in an array, I will use reduce functions. Right? The first one is accumulator. The second one is kernel. Right? So for each iterations, when I add accumulator with initially accumulator will be start 0. So after iterating every number, we have sum of all the number, right? So okay, that's fine. So let's double check it here. I copy this line, paste it here. Now let's say we have 1, 2, 3. Right. The sum of 1, 2, 3 should be 6, which is correct. Right. So yeah, that's pretty much it, I think. But if you run the code right now, it will cause an error, right? Just so if you're coding with me right now, you can pause right here and try to debug by yourself, like what is the problem here. So 2.2, okay. Okay. Return, I forgot to return after here. I need to return best path. it's still not the only problem here. So actually I faced this problem and figured out that the best path here is something that's causing problem, right? So because it is an array, so because here we directly modify the best path here, right? So the best path here, so for example we are at 4, so we come here, it's a leaf node, we come here and sum of the current path is greater than here. I want to update the best path to the current path, but actually we don't want to reference here because the current path will change, right, as we popping our element here. So we want to have a copy of it, right, and to have a new array. But the best part here, right? So let's imagine like if we are 7, right? We pass down the best path variable to the recursive functions at 4. So inside the recursive function at 4, we modify, right? We point the best path in there. We point to a totally different objects, totally different array, right? So when we come back to 7, the best path is still an empty array. So one way to fix it is to pass down the object, actually, the best path, and pass down an object, right? And here we're not going to update the best path variable, we're going to modify it, but let's say we're going to plug in a key for the object that is passed down, right? So we modify the key, but we not modify in the best path itself. So here, okay, and here we need to calculate sum of best path of current, right? Okay, I think that will solve my problem. Oops, still, okay, best path will return current instead. Okay, right, it works. So that's it for root leaf maximum path, right? So yeah, thanks for watching, see you in the next video.